talk today. Thank you very much, Mark.
Sure. So, welcome everyone. Thank you for coming. Sorry that the room is a bit too small. So this is the fourth time I'm giving this talk. Every time I remove slides and I still don't quite make it to the end. I'll try to do my best. I'll talk a bit quickly. Sorry if I do mumble, tell me, hey, we don't understand you anymore. And yeah, as a quick introduction, I've been working on Linux and operating systems for a while now. This is probably the fourth time I worked on doing a Linux distro and working about doing upgrades, which is really the hard part. Installing is easy, upgrading is harder. So yeah, I did in previous companies and then twice or almost 3 times at Google. So this was the third attempt, although it's our different environments, so each have different requirements, which makes the problem interesting every time. There's actually a much longer version of this talk as a Lisa paper. So if you take this URL either now or at the end, you'll have the link to the paper, which actually has a lot more details than what I'll be able to talk about in 35, 40 minutes or so. Questions, unless it's something that really doesn't make sense, try to write them down. I'll do as many as I can at the end. But then there's nothing else afterwards. So basically, I can be here as long as you want to be, really, or until the penguin dinner. Or you can catch me later also at dinner. What else do I have? Oh yeah, I have my special notes in a super small font, which of course I can't read. Fantastic. But yeah, that should be good enough. So let's get started. And display is good, very good. So just very quickly about Google, like any other company, the way it starts is someone has a Linux CD from somewhere, puts it into a server, then you get a second server, then you get a few more. Before you know it, you have a bunch of them. And well, you can't really just fix them all by hand, or you shouldn't be. So you do a kickstart to then run all your post-install scripts to do what you need. So far, so good. Then it's a few weeks or a few months later, and you have updates to install. So well, what do? First, a few machines, you do it by hand. You have a few more, you do an SSH loop. And then you have a few hundred machines, and you realize, oh, well, 3% of my machines were down during my SSH loop because they were being fixed or replaced or being installed, so they missed my updates. So now you're in trouble. The way they fixed that at the time, I wasn't there yet, was, hey, well, let's just reinstall RedHat 7.1 on everything. That will clean everything up and start over. Okay. Of course, well, not really a long-term solution, but at the time, not many people, a lot of work, so you do what you can. So yeah, how do you do updates? Well, anything that's pushed in the SSH or any other ways, really it's doomed, right? I'm sure people that here have done it. It's not a bad thing to do when you have a few machines, actually, but really when you have to start having more, not the way to go. Then out of curiosity, who runs apt-get upgrade or equivalent from cron to just install updates, either yours or security updates? Few? Okay. Who runs security updates blindly from cron? It's okay, I'm not. It's not an unreasonable thing to do until you get bitten, because the security update is not a backport patch. It's the new version of the software, which is not compatible with your config file, and it pushes on the Sunday at 3 in the morning. But it doesn't happen every time, right? So it may be okay to do if you have nothing else, but be careful about that. The next thing is, once you start having hundreds of machines, you realize that either RPM or dpackage or apt will find different ways to fail because the machine was out of disk, or it got rebooted, or God knows what, and it leaves locks behind that don't clean themselves, or in the case of dpackage, many ways it can just be in a state where you have to fix it by hand. Again, if it's my own machine, I'll log in, I'll look at what is wrong and fix it. When you're talking about hundreds or thousands or more, not really a good way. So I don't know how other people do it when you have thousands of machines, but you will reach those issues, and then one way to do it is just to ignore them, have them maybe get reinstalled. Instead of fixing the problem, you just wipe the box. But that's not really the best way. So yeah, at some point you're like, ah, crap. That's when you have few machines more than you wish you did. And at night you really, really hope you had this. That's actually, by the way, a real picture from a data center at Google. But shiny lights, right? So another way to do updates, which I don't know many people who've done this, but we actually did that at VA Linux a long time ago for workstations. We had a main workstation, which no one used, and you put the updates on it, and then you used rsync to push that image everywhere. It sounds crazy, but it's not as crazy as you think. Of course, there's a few flags to exclude network config files, stuff like that. But you make a big exclude list, actually it's not that big, and then you push that. It works. And you know, if the other machines get modified, people mess with them, then you sync back on top. Fantastic. That way they don't mess with what you're doing. It does work. The problem with rsync is that it's not really optimized to be doing this, pushing to 50 machines. It's rescanning every time if you do it at the same time. It's trying to scan the same files 50 times, never mind 10,000 times. So rsync is not the right program to do this at scale, but the idea actually works. So we basically wrote an rsync equivalent that caches all that stuff, that has throttling so that you don't kill the server, and of course you have servers, not just one, that you're syncing from. And then the machines you're syncing to, you don't want to be killing all their I/O bandwidth or their disk bandwidth, because if they're serving queries, you don't want them to time out. So you just put some throttling in there, but effectively that's the general idea.
Yeah, the upstream database.
So the idea is, we don't care. We push everything,
Yep.
right?
Yep.
So if you screw up your machine, whether it's RPM, whether it's anything, or if you install something else, somehow you got root on the server and you install your own things, we're going to write right on top of it. Of course, people at Google know that, but from time to time you get an intern or a new person who somehow gets root on the box. I'm not quite sure how that happens. And they say, yeah, every time I install RPM, like an hour later it's gone, so I have to put it back in cron and then reboot the server. It's like, what? No. The point is that, yeah, you don't put software on the root file system. I'll get it right there. So yeah, servers are all the same. That's what the root file system is. So they all boot the same. They all have the same management software on top. And then what they do, that's the software that runs on top, that is managed not by sysadmins, or we have SREs at Google, but by software engineers. And they get their sandbox to play with. They don't get root. They don't get to change the box. And that's how we keep things separate. That actually means that we can have more than one libc. We can have multiple versions of the same library. And the libcs, we do have dynamic linking. But for let's say you have 3 versions of the same library, you just statically link it into each binary. That way they can manage which version they want. And you don't have the upgrade problem anymore of, can I upgrade this math library without breaking someone? You don't know when you have 10,000 applications or more. You can't just test. You don't have the bandwidth to test it yourself, so you let every engineer maintaining their own app take care of that. And if they never want to upgrade it works for them, you know what? I don't care. Works for them, right? Upgrading, today you feel like you have to upgrade all the time. It's like, why? If it works, you don't need new features, just keep it, leave it alone, unless it's a security issue, of course. So, so the root partitioning, well, obviously we do have to do upgrades, but not nearly as many. We don't, of course, run standard stuff like Apache, since we have our own servers, so that all goes into the sandbox that we don't manage, as in us, the people who take care of the OS. So really, you just have to upgrade things for security, which if you have a small distro is actually not too bad, because there's not too many programs. And then you have to upgrade things when you need new features, like maybe do you want a new syslog daemon that can do a different kind of pattern matching or throwing away logs that you don't care about, stuff like that. But not that many, which means that in the end, we end up with running Red Hat 7.1 for a long time. So how do you do base package upgrades? Well, as I was explaining, you basically have a master image, and you install upgrades in that image, which is effectively something you shroot into. You put your new packages. You make that new golden image that you can run a few tests against, and then you snapshot that. You put in some source control system. We have review tools that were able to review diffs of images, showing you exactly how the files changed. If they were binary, well, you had some kind of binary diff. If they were text, you had a full text diff of what changed. Then we had SREs that would review that line by line and say, okay, I think that new image should be okay. And then you push it for testing. And we only have 2 images. We have the current one and the new one. That way you don't have to worry about having 10, 20, 30 images out there. And then when your application doesn't work, you don't know which image you're on. So the question you haven't asked yet, but you probably would have, is, wait, so if you're syncing files, how do you run post installs? For some post installs, like generating symlinks for libraries, from ld-config. That's not a big deal. You run it on the golden image, and that gets pushed. But what if your post-install actually runs little, or post-install restarts daemons, or does something like sharing SSH keys for each host keys for each machine? Of course, if you have the same host key on every single box, that could be bad. So for that, we have triggers, which effectively, our syncing daemon has a watch on some files. There's a config file for that. And if a special config file, well, if a file in that list gets touched, then it has an int script that it can run for each. And that's really a cheap way of doing trick, basically, of knowing that something changed and rerunning a daemon. That, and in the case of SSH, for instance, you could have the SSH init script say, oh, there's no host key on that box. Let's make a host key first, and then run SSH. And that works actually quite well. All right, so I'm still waiting to get a medal for RedHat for running RedHat 7.1 for 10 years, but it never came. I check my mailbox every day. So, well, obviously, we patched it for a long time, and it worked well enough. So, many machines, it works. You have to make a case for changing. Like you have to have enough pain to make a case for changing something that big and making a big diff. And people in the past were like, well, it works well enough, so let's just leave it alone. But as you can guess, it doesn't work forever. So we need to have a new distribution and decide what it had to do. And realizing that, well, if it's a 10-year jump, userland changes a lot in 10 years. So it's going to be a scary jump regardless of what distribution we use. Oh, and by the way, if you could now reboot the machines, that would be nice too. Small detail. The machines, by the way, do reboot for kernel upgrades, but that's it. We don't otherwise reboot them for no reason, like a 10-year distribution upgrade somehow. All right, so we actually had RedHat a long time ago on our workstations. That's why we had the same thing in production, just to keep it the same. And then we did switch our workstations to Ubuntu. So the reason at the time was just because there were a lot more packages in Debian and Ubuntu. They were in RedHat. And we were just tired of packaging so many things by hand. It did get a bit better over time. But last time I did this, which I think I did that count maybe a year ago now, you can still look at RedHat, see that Debian had about 3 times more packages. And back then, it was actually 10 times more packages. So RedHat Fedora is getting better, but it's still a bit behind. Then there's other reasons. I'm not going to go into all of them. But anyway, so Ubuntu at the time made sense for the workstations. So that's what we got for the first replacement distribution for the servers. That was the days of Ubuntu Dapper, which was still a reasonable distribution. I'm sorry if I'm going to give a small personal opinion here. It has gone a bit downhill since then, my personal opinion. That's not the opinion of my employer, just my personal opinion. And by the time it started being more things that were graphical and workstation related, that made it harder for us to work on servers that don't have keyboards, don't have screens, of course. It just didn't make sense. Upstart, and I'll go into the Unix scripts quicker. I think it's the next slide. Actually, I'll just look at the Unix systems. So when you choose a new distro nowadays, it's, oh, what Unix system do you want? Well, of course, SysV init is the one that everyone's had for a long time. That's what we had. And it's simple. It's full of shell. It's all different. It's not great, really, but it works. And the thing we like specifically about it is that it boots the same every time. It's serial. It takes its time. It's maybe a minute. We don't reboot the machines very often, and we know what we get. Then the next one, of course, is Upstart. We use Upstart in Chrome OS, for instance, where we have, I think, a 4.5-second boot on it. That makes perfect sense there. System would probably be doing just as well. But on our servers, if it takes 30 seconds to boot, it's not the end of the world. So Upstart, very quickly, different syntax, of course. The bigger problem is it doesn't give us a specific boot order. So if you take the same machine, boot it 3 times, it might boot differently. At the time when I had Ubuntu on my laptop, networking would not come 1 time out of 3 and would deadlock the boot. And I know I have like lines and lines and lines of like debug things going on my screen trying to find out what signal it's waiting for. And it's just very time consuming to debug. And when you have a server that doesn't even have a console, it's just time that you don't want to spend. So the idea is you may have a bug. I mean, of course, in this case, there was a bug in Ubuntu that caused that. But in our case, we may have a bug that hits 0.01% of the machines, and if it rolls out, now you have X machines that are down, and it's not enough to be caught during testing because we always have a noise of failures. There's always some amount of failures. So if you have a race condition that doesn't happen often enough, we're now going to catch it early, and then it might deploy everywhere before we realize, oh crap, we actually have a race condition here that would be the same in Upstart or systemd for that matter. And by just booting serially, it means that, yeah, we're just taking the easy route. We don't do concurrency at boot time that we don't have to worry about as much. But that way, we have one fewer list of problems to worry about. So systemd, same thing. It's a different system. I'm not going to go comparing everything with them. It's even more changes for us because now it's not even compatible with shell init scripts at all. It does offer even more things that are kind of nice, and we may look at eventually. But it's so many changes for people who are used to doing things a certain way that it has to be worth it. And the same problem in Upstart, the race condition issue, if one developer makes a mistake, that they depend on something, we have a lot of cross dependencies between our tools. If they don't work themselves out every time, then we could have issues. So for now, it's not been worth the switch. But the reason I'm mentioning all these is because number 4, most people don't actually know that well. And there's others, but in the case of Debian, there's an Insserv, also called startpar, depending on which script you look at. And long story short is you put the dependencies, you hardcode them in your init script at the top, saying what you depend on. And using that, it will run a command that will reorder the numbers on your init scripts. So it's a poor man's concurrent boot. But the reason why I really liked it is because it will reorganize those init scripts. It will give them new numbers. And then you can look at it and snapshot it and push it the same on every single machine. So it's not going to be as fast as Upstart and systemd. However, if you want to boot a little bit quicker than just a serial one-by-one boot, you can get that and have something that can be reviewed from a snapshot. And you can say, oh, OK, I think that order will be fine. Whereas the other two, you'll never know how it's going to boot. You just hope it works out. Which, hope is a strategy, but we use it as little as possible. ProdNG. So that's the new distribution that I had worked on for, I guess, a bit over 3 years now. The ideas we had made for it was self-hosting, which the other one was not. Like we had basically, I think rebuilding RedHat 7.1 from inside RedHat 7.1 was not even that trivial. Never mind 10 years later when the compilers don't even work anymore, and that's old source, right? So that one is really is entirely built from source, whereas the other one was actually a binary snapshot of RedHat 7.1 with a bunch of overlays, which of course is not that great. All the packages are, since they're rebuilt, we strip everything we don't need in them. So for instance, saying, if we don't use SE Linux today, then there's no reason to put in the binary. If we decide to use it tomorrow, then we can add it. But in the meantime, we don't carry a library for X years that might have bugs or just adding bloat that we don't need. And for us, memory is very important. It costs a lot more than hard drives. So we want to keep all the memory we can. That means not adding bloat or any libraries or any code we don't need. Then the next thing, of course, is less is more, right? So you want the smallest distribution possible because that's what gets pushed over the network for each reinstall. It's also what gets pushed for every update. And the fewer packages you have, the fewer bugs you're going to get, the fewer security updates. Anything complicated like, again, Upstart, people might laugh like dbus. You can actually work without Debian on that, or even, of course, Plymouth. It's just things that get in the way. And if you don't benefit from them, my personal advice, don't use them. They do provide features. Make sure you need the features to actually use that. OK, so I went to the rest. And the next thing is, new packages are not always better. I remember I had to upgrade RPM at the time because I needed new features. But now it added all those extra things like XML2 support and a bunch of other stuff that I'm sure made one person happy, but we really didn't need. So you just take all that stuff out to have a smaller binary and not carry new libraries that you don't really need. And of course, hermetic. So now it's the image and the packages are built within the distribution itself. So it unpacks the distribution, it puts the new source, it builds it within, and spits out a binary. So you can build a 32-bit package into a 64-bit system. You can even actually build that on a Red Hat box, even though it's building Debian, because it's just fully self-hosting. All right, and I'm racing. I have more details. I can go back if we have time. I don't know, we'll see. So now we have a new image. How do you push it? So as I mentioned, the file sync, we can totally file sync over the entire colos on all the machines. But the problem is you still have a 10-year jump. It doesn't matter what distro you have. And a simple thing like core utils, when you jump from v4 to v7 or v8, there were so many changes that just break every single shell script to make POSIX people happy that it's not fun. And when we had both distros, they were like over 20,000 files. They were different, obviously. And there's just no way to review that sanely. So we had that distribution, and then we said, well, no one's going to let us push this, because how do we convince people that it's going to work well enough? And so people will say, hey, we can maybe just push it slowly. Push it a few machines at a time, a few hundred machines at a time, a few thousand machines at a time. But then you hit a problem, someone says, oh, stop, so now you have to roll back. And you go one step at a time, you go, you roll back, you go, you roll back. Or it takes a very long time to push to all the machines, and it could take over a year where you have a fleet that's in between two states, one being Red Hat from 1999 or 2000, and one being something 10 years newer. And never mind, one's in RPM, one's in debs. So now when you push new stuff, you have to make sure both systems that are totally different. So on the maintaining part, you're now maintaining two different systems for over a year. And then when you're debugging, now again, you have an entire fleet for a long time that's running two different systems. And I'm saying 1 year, I'm being optimistic. I have no idea how long it could have taken, but it just didn't sound like a great idea. So yeah, no good. What do we do? Shopping, no. Okay, so I think I went through all of this. Yeah, so the flag day, obviously there's a flag day when you switch from deb to RPM, but as I mentioned, or RPM to deb, but as I mentioned, we don't use RPM or deb to deploy software on each machine. So that part was not too important. The service owners being the ones running software on top, they should not even care that we switch to distro. Their stuff should just keep working. So the packaging system is really important to only the few teams that work on the base image, which is not that many people. So that's actually okay. And then we do have a motto, which is don't create work for others unless you absolutely, absolutely have to. So don't be lazy. Just do everything you can so that other people don't get impacted. And that was exactly what we tried to do. But now we also knew that we couldn't do that big jump. So how do we do it? Well, if you can't make a big jump, make small jumps. And what does that mean? It means you take Debian and you put it little bit by little bit in Red Hat. That can't be so hard, right? At least it sounded good on paper when we started. So the first part, well, let's see how crazy it is and see if it works. So the first part was, well, the libc is probably the important thing to sync. And at the time, the versions were off by a little bit, but not enough that it was a big deal. So we put the Ubuntu Dapper libc at the time into that Red Hat 7.1 system. And there's a few things, few binaries that were slightly unhappy, but not too many. So we're able to upgrade them, and that was all right. And the other part was basically we're building those debs into our ProdNG system, which basically was a virtual system. It fully worked, but it was not used anywhere. And then when it was done, it would spit out a deb that would be converted to an RPM. Alien, of course, does a great job of that, except for converting the dependency names, which are not the same between RPMs and debs, and also changelogs. Most people don't care about changelogs, but we do because they're part of the review tool. And they're very different formats. But that's nothing that can't be fixed. Then pre-post install scripts, well, that's also a problem. But as I mentioned, we don't use most of them because they don't work in our system. So we didn't have actually that many. And if all it does is run ld config, well, that's going to run just fine. The rest is basically a case-by-case fixes, but it, again, wasn't too many things to fix. And set stuff to say, hey, trying to get it right. In Red Hat, it's called glibc, in Debian, it's called libc6. So you just set one into the other for dependencies, and so that your deb package would install properly on an RPM system. And from there, say, well, let's see how far we can get. So before starting to upgrade a bunch of stuff, came, wait, why do we have this? Why is that package there? And the other part was, why is our image, I think at the time when I started it was 650 megabytes. That also included specific Google software. But the idea is it had, I think, over 300 megabytes of stuff that I was just able to remove. It was part of Red Hat 7.1. That was back when Red Hat wasn't big. And I say Red Hat, it's true of all the other ones too. And it's just, yeah, it's shipped with like X fonts and a bunch of things on a server that didn't even have, running X, right? Then locales for languages that we were not going to use, keyboard mappings on machines with no keyboards, stuff like that. So I went through all the packages, including the libraries that just somehow came with the system that were either orphaned or not used at all, removed them all. Things using libwrap, remember send mail, TCP wrappers from last century? Yeah, so don't need that to compile without it. And the interesting thing is, by the time we're done, actually, there was not a single binary using C++ anymore, as in part of the boot system. We do use C++ for our own software. But I think the only one was graph, and we didn't need that anymore. So that's one more binary that we don't have to upgrade. So once we're done with that, we did notice a few issues with static binaries. That's always an issue because they hard code path names of NSS libraries in your binary. So even though you switch your libc, they're still calling the old one. They may not be fully compatible. And whoa, that didn't quite render properly. But there's a few signals that didn't quite match. So we had to recompile a few binaries. But they were pretty few. And then you start with a few small packages, and you work your way up. They were done a few at a time, every update. So we did not just push 50 of them and say, oh, it broke. Which one was it? And yeah, I mean, this, I'm fast forwarding, right? This is like probably 2 years later. There's one package that was called Red Hat Release, and all I had was one file called Red Hat Release. And it said 7.1 in it. So I was like, well, that can't be that important, right? And it was more like, this system is not Red Hat anymore. There's no reason for us to pretend that it is. But obviously, yes, in this case, it was being used by something. And the way it works at Google, but really most companies, I'm sure, is it doesn't matter whose fault it is. The last person who touched it broke it and reverts it. So that was pretty much always me. So yeah, and then you try again later. So yes, I have the meme that goes with that. There's many more that I'm not allowed to post, but you get the idea. So going this way, basically, yeah, we did all the upgrade of all the packages. It was about 150, which actually is not that many, but if you did them one by one and then push them a few at a time, it did take a bit over 2 years. And also because it was only pretty much part-time for one person, which made it a bit slower. But really, throwing 10 people at it would not have helped that much because, as I said, we only want to push a few things at a time so that if something breaks, you know what to revert. So yeah, you take your time, be patient, and then we eventually got to a state where the Red Hat image and the ProdNG deb-based image were almost the same. The only thing, all the packages were the same because they were built in one, pushed into the other. So all the last bits of Red Hat had been purged, except that one package called initscript. That probably doesn't do anything too important, right? Well, so basically, yes, it's all the boot system. And of course, between Red Hat 7.1, which wasn't LSB compliant because it didn't quite exist back then, and Debian, it's all different. And that took a few months of work to go through the entire list of the scripts, and plus all the stuff that we had added to it to boot our servers in special, interesting ways. I do have a slide later that probably won't have time to, but for instance, we bring up SSH before the file system is even mounted read-write. So you can SSH into a box if basically if the machine isn't booting, you can get into it very quickly to see what's wrong. Lots of things that we do like this. Find issues with machines, report them to servers so that they know the machine is not booting properly and why. And then we have automatic scrubbers that go and reboot, poke them, reinstall them automatically to not have people do it by hand. So stuff like that. Also, let's see how much time. Very quickly. So another thing we did also was if you FSCK the root file system and you modify it, then you typically have to reboot, which makes the boot slower. And also, it's kind of difficult to get the output of that log because it's not written anywhere since you didn't have a writable file system yet. So what we do is we have a init.rd that you pivot root to, so you can actually free up the root file system. Then you can fsck it, you can capture the logs, and when it's all clean, you can pivot root back to it. So you can actually fsck your root file system, keep the logs without rebooting, and then save the logs all in one swoop. Stuff like that. So that was a bit difficult to port, but nothing that can't be done. Now we had the other issue that I was converting devs into RPMs. We do have third-party developers who were adding their own packages into the base distribution, and those, some had converted to devs by then, some had not, because they had a package they never touched that kept working. So now I have to convert those RPMs into devs. It was only a few of them, but same thing, converting the change logs, which was a lot less fun the other way, because the RedHat ones have no syntax, no checking, no nothing, whereas the Debian ones sure do. So, but anyway, Alien, more scripting to get there. And let's see. Now, yeah, so basically now we had the init scripts and an image that we could now say, hey, it's almost the same. So pushing this should not be nearly as scary. The file diff was about 1,000 files, and most were actually Debian database files, because in RedHat, as you may know, it's just a few files of an entire database. In Debian, it's one file per everything. So that's mostly what the diff was. And we have a regression tester for every single image we push that basically runs a bunch of forward and backward tests to see what happens to the image and the daemons. You crash reboot it, you revert the image while it's running, you make sure all the triggers take care of everything. So we use that, and that passed. And then at that point, we could start pushing it slowly to machines. So you push the button, and then you back away slowly. But no, not quite. First of all, because yes, always problems when you're on vacation. People can find you. So really, obviously, we were around, but nothing really bad happened. We just start pushing to our canary machines first, and then we use a percentage of machines to continue pushing. And the only thing we found was Varun that had become a tempfs when it was part of the root partition before. There was one thing that was writing a file that got too big depending on what hardware you had. And we hadn't caught that one. But I mean, that's kind of a small detail. So we fixed the daemon. Of course, at that point, it does mean revert. Fix the daemon, push the new daemon, and then try again. And after that, it was all good. So most of the time was actually spent helping our internal users of the distribution switch from the RPM builds to Debian builds, because that's kind of different. The diffing tools were also different. We'll see if we have a bit of time at the end. Before, we were diffing binary images. The new one is built from scratch. So that one was a tar file that would get unpacked from the before and after image. And again, it would give you a diff of each file that had changed, so you could review that. And some things that were like tar files, or we have a Python archive, they would get unpacked, and it would show you a virtual diff of what was inside to help to do a better review. Now, we did actually consider supporting RPMs and debs into the same distro. We even had code that did that. It's not actually that hard, but we've realized that, well, first of all, we do want to remove as much as we can. The second part is, if we keep supporting RPMs, then our developers will never switch to debs. At least some of them will never switch. So we figured, hey, you know what? It's going to be easier to give them a deb converter. If you still make an RPM, run it through that. It will spit out a deb and just give us the deb. And we don't care how you built it, as long as the bits inside are good. The rest is your own problem. So the only thing we wanted to have still was RPM to CPIO. In case you were into a machine and you had an old package you wanted to test, we just wanted to give you that option. But turns out that RPM to CPIO actually requires all of RPM just to unpack the damn thing, because it's not a standard format that anything can use. But maybe a little bit of shell scripting could do that. Besides this, obviously, again, someone's written a meme for it already, so you don't have to do your own, or a shirt in this case. But if shell script is not good enough, you can even down to an alias. Yeah, we have a lot of stupid jokes at work. So it didn't go all the way to an alias, but indeed, this is RPM to CPIO, not in 4 megabyte format. So, of course, it's very readable, but so is the other one. So really, you're saving space and everyone wins. That wasn't my code, by the way. That's a URL of whoever wrote this. So now things are good. Lesson learned. So if you have the option and you're maintaining many machines, you may want to look into maintaining your own Linux distribution. Of course, not from scratch, but take a fork, mostly to remove stuff you don't want. That way, you don't have to worry about those bits. You don't worry about security updates anymore if you don't have those packages. And it also gives you an insight of what you're running. Because nowadays, I'm not picking on any distro. Linux has become really complicated. It has so many things that it's difficult for one person to understand everything. So if you need those bits, great. But if you don't, just take them out. Next thing we did through that process was defining an API saying, hey, this is what we're going to provide to you. And if you somehow reach into the guts of the system and start taking those libraries that you're not supposed to see, we'll upgrade and remove them, and we'll break you. Of course, again, finger pointing doesn't work. So the way we did that was we give people a shroot in which they only see a portion of the root file system. And we basically have an exclude list where we can remove all the files that we don't want our applications to see. And as time went by, we started adding more things to that exclude list, so the system they saw started shrinking more. So that's one way to slowly make that API smaller. And that way, everything you've excluded from our users, we could remove from the root file system or upgrade it, knowing that we couldn't break anyone anymore because they couldn't see those files. I know file syncing sounds crazy, but it does recover from every single possible state you can have. So, and it's the same mechanism you can use to install the machine, so it's really a double win. And you can do crazy things like switching distributions if you have nothing else to do. Upstream updates, I already mentioned that. I mean, of course, Trojans is one thing to worry about, but really, it's more, even if it's not malicious, it's easy to get a new version that has not incompatibility problems. So be wary of that. I did mention that already. Yeah, just if you don't need it, remove it. I'm not going to go back there. Next one is, of course, for servers. You probably don't want to run the shiniest either Ubuntu, Fedora Core, or Debian Unstable. You probably want to have something that updates every 3 or 4 years. But if you run your own distro, the part where you, especially on the Debian side, the part where you win is you can take that stable one and add the stuff you need as you need it. And you don't have to forget it for 3 years and 3 years later wake up and say, ooh, I have all those things and they're all changed. And now I can't convince anyone it's going to be safe again. So instead of taking those big jumps, take smaller jumps, or not even jumps anymore, just small updates. That way you control the bits one by one. And if something looks bad because now you're only grading a few packages, you can see what's inside. Say, hey, I don't want that one. I'll just keep the old one. And the last one was, yeah, same thing. So this is not, this is not me saying that means the best distro. It's more like it allows you to do a piecemeal upgrade, which most other ones do not let you do. Or they even tell you if you do this, it will break. I've even seen Ubuntu have code that says, hey, if you jump from here to there, it will break. And it's like breaking UDEV so your system doesn't boot. So keep that in mind when you switch or when you choose. All right, so the rest, there's more, but obviously time is not something we have. So 1 minute, how much do we have left?
5 minutes.
5 minutes, oh, perfect. If you are crazy and you want to do stuff like that, we do hire. And not the rest. I do 5 minutes of questions, and I'll just be here for as long as you're here.
So, how many machines were you updating? I guess that.
What's the number of machines at Google?
So I mean, this is for all the machines?
Yes.
Is that right?
Yeah, all the production machines are running all the same Linux.
Okay.
I mean, the applications on top are different, obviously, but
Yeah.
the OS under is the same.
But wouldn't it, what you've done, it makes sense where you have a very large number of machines that are all the same?
If you have over 10 or 50 machines, in my opinion, it's the same problem. If you're doing this with 100 machines by hand, you're fooling yourself.
Surely with if you've got 50 machines,
Mm-hmm.
using the upstream provided updates is going to be less work than rebuilding custom packages with each security update.
So for some things it is. There's two issues. One of them is the jump. Like if you're just sitting on it until the next LTS, now you have the big jump again, where you're not sure if you can jump, and if having 50 machines doesn't fix that problem. The one where you say, hey, I don't care that I'm using a bit more disk space, I can afford a bit more hardware because I'm not as, it's not the same amount of money, then you're right. At Google, obviously, saving 1 meg of memory, we have a table that says 1 meg of memory is worth that many engineers, right? Fleet-wide. Yeah. So, of course, then the scale is different. So for that, you have to make your own trade-offs. Correct. Yeah. Yes?
Was any of this stuff generic enough to be upstreamed, or is it all very, very Google specific?
So defined stuff. The distribution itself really is just a rebuild of Debian.
The tools you built to allow you to jump to a switch distribution.
So the only tool that really involves the file sync. The rest is really just glue shell. That's kind of custom and not very pretty, but nothing, there's no real science in there. The rsync replacement, unfortunately, was written at Google using all the internal Google software and logging in all that stuff. And then once you take that out, nothing works anymore. So since then, we have written software with the idea of either upstreaming or releasing it. Like all of Chrome OS was written that way. Stuff like Garrett was written with the intention they would go outside. And those people work twice as hard because they can't use any of the nice libraries we already have. They have to rewrite everything because they can't touch that internal stuff that we can't all release. And it's not like we don't want to give a piece of it, but it's all intermingled. We can't just give a bit, you'd have to give everything because the developers are using all those bits together. So it's kind of difficult. So the file syncing piece, unfortunately, that is not something we are able to release. Yes?
I'm just curious, if you're doing rsync sort of on a file level, couldn't cache file somewhere to speed up like the phone or the server?
Sorry, could you cache?
Could you cache file fingerprints or something on the server or something on the client so they're faster?
Yeah, we do that. I mean, there's of course a lot of optimizations.
Okay.
It's not rescanning everything. The server that's pushing the files has everything in RAM.
Okay.
It knows all the checksums of all the files.
See, it's just
with
really you're saying it's quite slow to push out to an rsync thing.
Right, so the server doesn't do any work because it has all the I/O work of talking to you, saying, hey, what do you have, and this is what you should have. The other bit it does is it pushes all the files to you in change sets, and then when the change set is ready, then it switches all the files over very quickly so that you don't have a half-synced system. You could do that with snapshots too, but the point is to be as atomic as possible. Yes?
So about one of your lines in the talk is about doing this live.
Yes.
But within it, there's a number of dependencies that will require reboots. Over the period of the transition, you're changing kernels, you're changing glibc, were you changing Lilo, were you changing?
None of those require reboots except kernels.
Except kernels.
We change init. We can I don't know if you can with Upstart. With the old init, you can re-init itself. You can restart itself. If you change the libc, it's okay. You just keep running the old one. The new binary is there until you reboot.
So everything's still running Lilo?
As far as I know, because why not? It works. It works for us. The day we need cruft, we'll switch to cruft. It's more like, again, shiny, if you don't need it, why? I'm not saying that Lilo is better, but it was there then and it's still there today because we haven't had to switch. Yes?
I'll just check my statement first. But, in a lot of respects, you basically re-implemented Gentoo.
Yes and no. By the way, we do use Gentoo in Chrome OS, which is the team I work in currently, so I'm quite aware of Gentoo. There were reasons. So we already were using Ubuntu on the workstations. So the idea was to keep the same system. The part where we are rebuilding Debian is not really the things that Gentoo do, the use flags and so forth. We didn't really spend much time on that. It was more the review time of saying, hey, so do I want this library on the system? Then, of course, you have to rebuild the packages that need it without it. And then you have to release and push them. And every time you do that, you go through the whole test cycle and all the overhead of getting it reviewed. That's what took more time. You're right that Gentoo makes this a little bit easier. But then we had on top prune package that even takes that binary package and removes all the stuff we don't even want in the package, but we build anyway, so we don't have to modify the source if we don't need to. So let's say there's a lot of packages that we just built and modified, and then there's a filter that removes like half the files in it because we're not going to use them. That way we end up with a smaller package. And we also have some craziness that looks at the MD5 sims of the files before and after. And if they're the same, it changes the dates on them to match the dates of the old ones so they don't get synced just to push a new date. Stuff like that.
So
Yes.
Up the back was one.
Oh, sorry, yes.
Last one.
With all the time and energy that was spent, ultimately, would it not have been a lot easier to just set up our system and literally just swap in with a reboot, like we take one down, put the other on?
So that's what.
Would you do it that way?
So it's not a question of swapping the system. It's the question of, are you talking about when, the whole upgrade piece by piece as opposed to just saying, here's the new one and we'll just swap it slowly, machine by machine?
Yeah, pretty much.
So that the thing I mentioned was they would not allow us to do this because now you would have a fleet with 2 different systems for quite a long time. I'm just guessing a year, but it could very well be a year or more. And now you do twice the work. Every package has to be built for both systems, tested for both systems. And then the application developers on top are now running on top of 2 different systems that they have to test for. And if there's a bug, the SREs are getting woken up at night, wonder, it's a 3% failure on what kind of system? So it was just too much work for too many people compared to what we did, which was a lot of work for me, but a lot less work for the other people.
I'm sorry, that's going to be the last question.
Okay?
Thank you
I'll
very
be
much.
here, so just, yep.
Can you please thank Marc again?
Thank you.